Hey YouTube, welcome back to trigonometry. This is true variance, a subtopic from trigonometry. Actually, it's about directions, how you can measure the angle from reference direction. In this case, it's north 1. And this stuff for GCSE and IGCSE Foundation and Higher Maths. Welcome back to Maths with Daniel Dallas. If you're new here, just subscribe and smash the bell button to be notified about daily videos that actually I create. Okay, and you'll stay actually tuned up. Let's get to go. So first, I just give you a brief idea of bearings. Let's say you stay in point A, and that's your initial point when you face towards the north direction. Let's say this is north 1, okay, north direction, and you want to measure the bearings, your final point destination, basically B, from your initial point A. That's what is called bearings. So bearings actually is the angle measured from north direction in clockwise direction until you reach your course, basically the segment AB. So B is your final point, and you actually want to measure this angle in clockwise direction from north as the reference until it reaches your segment AB. So this angle is around, let's say, 120 degrees, roughly. Or normally you need to use protractor in order to establish the right measurements for your angle. But sometimes you need to calculate the bearings if you're given, let's say, initial bearings. Let's say you're given bearings or bearing B from A as 120 degrees, okay? And you want to calculate bearings. So you want to calculate bearing of point B, point A from B. As if you're staying, so find the bearings, point A from B. As if you're staying in point B, and you want to measure bearings point A from point B. So basically what you're going to do, again, using the rule for the bearing, so you need to stay in the point B, because from that point you're going to measure bearings A. So that's why you stay here, and that's your north direction, north, and you turn in clockwise until you reach your segment. So that's your bearings actually that you're looking for. So you're given your initial bearings, which is 120. Let's suppose you're given your initial bearings. How to measure these bearings? Let's set up as angle X. Okay, what are you going to do? You need to use the theorem about parallel lines, okay, parallel lines that goes through initial point B and your final point or destination point A. So if you set up two lines that parallel to north direction, and actually that goes through point A and point B, you can use the theorem about alternate angles. So I just remember alternate angles, if 120 is one angle, so this angle from the blue segment to the green one, this part, okay, I just mark as black, is going to be the same angle according to alternate angles theorem. So this angle is 120 degrees. So that's why on top of that, angle X is simply your angle 120, and on top of that you need to add 180 degrees, which is the open angle from that side. That's how you can calculate the bearing A from B. Basically, this is the course on the way back. So if you start from point A, you moved at the bearings 120 or at the course 120 degrees, and you reach the point B. Then you turn back and actually you flip your direction and the way back. So that's why your starting point now is B. You set up north direction right there. Then you measure the angle or calculated the angle as the bearings to the segment BA, then how you find the variance A from B, and this is your course the way back. Okay, so in total, if we add up the two components, basically open angle 180 and from here 120 as an alternate angle, you'll get the full complete variance A from B. So let's add up and we'll get 300 degrees in total. Okay, so actually you understand that variance involve parallel lines and the theorem about alternate segments. Okay, if you have more complicated case, let's say you have triangle, maybe we can also use triangles. So let's set up a triangle here. So we have initial point A, let's say we have another point B, and we have the third point, let's say C. So from there you connect course from A to B, that's the first course. Let's set up even as the vector, maybe the blue one, okay? So from A to B, that's one course. Then, and let's say this course goes at the variance of 120. Let's set up north direction right there. Oops, actually change the color. So that's from north direction, which is here. You can say that this variance is around 120 degrees. Then when you reach point B, let's say you traveled 5 kilometers, so AB is 5 kilometers, then you turned to the next course to point C. From B to C, you move a different course, and again, you can establish north direction, say, okay, here's my variance from north, from there, in the clockwise direction again, and let's say your angle is definitely less than 270, let's say 250 degrees. Okay, you have two variants, and you worked another, let's say 6 kilometers. What to do in this case? So probably you need to find, I don't know, probably the shortest route from C to A. So right now you're at point C, and you need to find the distance from, let's say, C to A, from your original position. So how to work out the distance? I'll give you just the possible way that you can determine. So first of all, because you have two sides, 5 and 6 kilometers in the triangle ABC, so you can consider triangle ABC, and you can actually say that if you know this small angle, which is, let's say, x, you can figure out distance. What theorem you are going to use? So in general case, you will use cos rule for the triangle. So if you use cos rule for the triangle, you'll get d squared equals, so two sides, square of two sides, okay? You add them up. This sort of Pythagoras, but there's a little adjustment for, according to cos theorem, as 2 times those two sides, 5 and 6, and times cos of the angle between them. In your case, angle is x, so you can say that right now you have cos x degrees. So in this case, you need to figure out x angle. If it's 90 degrees angle, so there are two cases. If it's 90 degrees, I mean your x is 90 degrees. In this case, cos 90 is 0, and you have perfect Pythagoras. So basically, if you can establish that your angle x is going to be 90 degrees, you'll use the shortcut using Pythagoras, because your triangle is right angle and you're looking for hypotenuse. But if it's not, that's case 1. So if x other than 90 degrees, so you just need to use that calculation. So basically you need to use, so use complete cos rule or cosine theorem for the triangle. So basically what you can see here, okay, I'll just highlight that. Okay, so this is the general approach how to work out the distance d. All right, let's have a look in our case what it looks like. So you have 250 degrees is the complete bearing, but you would like to find the angle x. Okay, what we're going to do, we can use again the theorem about two parallel lines. So just simply prolong north direction down. So from there, I just put down one line, which is parallel to north direction, and another two parallel lines. Okay, so in this case, I understand that angle 120 is right there, and it also, as according to a theorem of alternate angles, so another alternate angles is going to be that one. So this angle is also 120 degrees. So we can write that 120 degrees consists of angle x and the small part which is here. But we know that it's 250 minus 180, right? If we subtract 180, we can get this small black angle. So I can just shade this part. So this part is actually this black angle, which is simply 250 minus 180, okay? In this case, we can calculate this angle as 70 degrees. So this blackish one is 70. So what we can say that x in degrees is going to be 120 minus 70, which is actually 50 degrees. So now we know that angle x is 50 degrees. So angle x is 50 degrees. So we are not going to use Pythagoras because it's not 90 degrees. And we're going to use that theorem. So let's calculate that. So that's how we're supposed to do. So we just use the formula. D squared is going to be 5 squared, 25, 36 minus 2 times 5, 10 times 6, 60, and times cos of 50 degrees. Okay, so cos 50 degrees. And then you add them up, you do calculations, and then take in the square root of that. So let me grab calculator quick. Sorry for that. Okay, so actually you can use your calculator. Mine is a little bit stuck, sorry. Okay, now let's wake up. All right, so what I'm gonna use? I'm gonna use basically square root of 25 plus 36 minus 60 times cos. Make sure your calculator is in degree mode. So in this case, what I've got D is around 4.74 kilometers. So two decimal place. All right. So that's my answer, and that's how you're supposed to calculate the distance and how actually you can find the angle within triangle. All right. So that's basically the idea, and that sort of questions you might have in your exams. This is definitely higher. It's not the foundation right now. Foundation it was before, something like this. And this is just foundation. And here you can extend your knowledge in order to work out different parameters of the course, or during the traveling problems, like according to what we have right now. Okay, so in next video, actually, we considered several examples where I can demonstrate how we can efficiently calculate parameters and how to find unknown values using the variance idea and using a bit more of trigonometry. All right, hope you like that, and see you later.